Welcome back. We're still on quadratic, and this should be the 5th lesson. And in this lesson, we are going to see how to use quadratic formula. That is, I want to use the quadratic formula we just derived to solve quadratic equation problems. So let's go. If I have x squared plus 7x plus 10 equals to 0, and the question is solve this by using the quadratic formula. So what do? You have to recall that the quadratic formula is an equation is of the form x equals to minus b plus or minus square root of b squared minus 4ac all over 2a. Okay, so if you compare the equation from the general form ax squared plus bx plus c equals to 0, you will agree with me that a is equals to 1. In other words, the position here, a here is 1. B is what is occupying the place of B is 7. So B is 7. What is occupying the position of C? C is what? 10. So C is 10. Next thing is to substitute this into the formula. So we say that x is equals to minus b. What is b? 7. So in the place of b, you substitute 7 plus or minus square root of b, you put 7. Then square minus 4 times what is a? A is 1. So you put 1. And then c is 10, you put 10, divided by 2 times a. What is a? 1. So you see, it's very easy just to substitute these values into the formula. So that means that x is equals to minus 7 plus or minus square root of. Now what is 7 squared? That's 7 times 7, 49, minus 4 times 1 is 4. 4 times 10, 40. So you have 40 divided by 2 times 1, 2. So x is equals to minus 7 plus or minus square root of 49 minus 40 is 9 divided by 2. So x is equals to minus 7 plus or minus, what is the square root of 9? 3 divided by 2. So x is equals to minus 7 plus 3 divided by 2, or minus 7 minus 3 divided by 2. So x is equals to minus 7 plus 3 will give you minus 4 divided by 2, or minus 7 minus 3 will give you minus 10 divided by 2. So x is equals to minus 4 divided by 2 will give you minus 2, or x is equals to minus 10 divided by 2 will give you minus 5. So these are the values of x. You can see how easy and how simple it is to use the quadratic formula. So I'm going to give us another example for better clarity. Okay, this is example number 2. We are still going to use the quadratic formula, which says that x is equals to minus b plus or minus square root of b squared minus 4ac all over 2a. So let's analyze. You can see that a will be 1, b will be minus 6, so you have minus 6, and c will be plus 9, so you have 9. Substitute into the formula, x is equals to minus b. What is b? Minus 6, so you have minus 6 plus or minus square root of b is minus 6, then square minus 4 times what is a? 1. What is c? 9. Okay, divided by 2 times what is a? 1. So that means x is equals to minus times minus is plus. So this is 6 plus or minus square root of minus 6 squared is 36. That's 6 times 6, 36. If you square minus, you have positive. Minus 4 times 1 is 4. 4 times 9 is 36. So you have 36 all over 2 times 1, 2. So x is equals to 6 plus or minus 6 plus or minus square root of 0, because 36 minus 36 is 0, divided by 2. So x is equals to 6 plus or minus square root of 0 is 0, divided by 2. So x is equals to 6 plus 0 divided by 2, or 6 minus 0 divided by 2. So x is equals to 6 plus 0 is 6 divided by 2, or 6 minus 0 is 6 divided by 2. So x is equals to 6 divided by 2 is 3, or 6 divided by 2 is 3. So therefore, x is equals to 3 or 3. So the root of the equation are 3 and 3. So which means that we say that the answer to this, we always write it as x equals to 3 twice. That's 3 repeats, equal roots. Now in the first example we solved, we saw that x was equals to minus 2 and minus 5. In the second example, we saw that x is equals to 3 twice. Please, these answers are very, very important. At this point, x is equals to minus 2 and minus 5. Minus 2 and minus 5 are two different numbers. So they give us two different roots. But 3 twice gives us equal roots. Why am I doing this? Because when we'll be talking about types of roots, I will make reference to this again. So it's important I start now to make you get used to it. So when we get there, we'll not waste much time. Okay, so we have equal roots. Here we have, equal, different roots. Here we have equal roots, 3, 3. So I'm going to give us one more example to really make us understand what I mean.
Mathematics.
Okay, so this is the third example we are going to look at. Now, if you look at this, we are still using the quadratic formula. So the formula x is equals to minus b plus or minus square root of b squared minus 4ac all over 2a. Okay? So you can agree with me that a is 1, b is 1, and c is 1. So let's substitute them into the formula. So we say that x is equals to minus b, b is 1, so minus 1, put 1 here, plus or minus square root of b square. What is b? 1, so put 1 here, 1 square, minus 4 times, what is a? 1, so you put 1. What is c? 1, you put 1. All over 2, these 2 times a, and a is 1. So that x is equals to minus 1 plus or minus square root of 1 square means 1 times 1, which is 1, minus 4 times 1 is 4. 4 times 1 is 4, all over 2, 1, 2. So x is equals to minus 1 plus or minus square root of 1 minus 4 is minus 3, all over 2. So x is equals to minus 1 plus root minus 3 over 2, or minus 1 minus root minus 3 over 2. These are the roots of the equation. At this point, you cannot simplify further. Why? Because the square root here carries a negative number. And in mathematics, the square root of a negative number does not exist. For instance, if you point your calculator, square root of minus 4, square root of minus 7, square root of minus 16, the square root of any number at all, your calculator will show you math error, syntax error. That is to say, it does not exist. But this can only exist in a branch of mathematics we call complex number, which I'll be doing justice to that in the course of my video work. But for now, just know that this thing does not exist. When we get to complex number as a topic in mathematics, I'm going to teach us what these things means. So, since we cannot further break down this, we just stop there to conclude that these are the roots of this particular equation, quadratic equation. So at this point, we say that the roots of this quadratic equation are complex roots. So the square root of a negative number is complex. So we can see in the first answer, first example, we had -2 and -5. The second one was 3 twice. And the third one is where we have complex. So automatically, when we get to types of roots, I've already taught you ahead that this is a type of root, this is a type of root, and this is a type of root. This type of root is called real and distinct roots. Real and distinct. The word distinct there simply means that they are different. Real and distinct. And then this one is real and equal roots. You can see that the roots are equal, 3, 3. And then complex roots, or we call it imaginary roots. I've even taught you types of roots ahead of time. So, as far as the formula is concerned, this is how to apply the formula in solving quadratic equation. So, in my next video, actually I'm not going to be doing graph in this particular video, but subsequently I will. But for now, I'm going straight to formation of quadratic equation, which is the 6th video. Let's get there.